Hi, so in this tutorial I will discuss about the secant method and how to derive its formula. So for solving it. So from Newton's method, we have our secant method here by replacing the derivative of the function f of x with a difference quotient. So basically, a secant method is used for finding the roots of an equation, of a nonlinear equation, such that our f of x would be 0. We write it down here, f of x equals 0, and used for finding roots. So we could find the root by simply observing this function, say that this is our function, this is our roots here. But we are applying the secant method so that we will know the value of this root. This is our root here. So for a secant method, first thing that we have to do is to take an initial guess. So say that our initial guess would be right here. At this point, we will name it as x of I. And then next step is that we have another guess at this part. We shall name it as x of I minus 1. Now for our secant method is that we draw here between the 2 points. Here's our 2 points. We draw a secant line. So this is our secant line. And then we're just going to extend this line. Extend it. Now notice that when this line crosses the x-axis, this is our x-axis, this would be the approximation value of our root. It is close to the original value of the root. So we will name this as x of I plus 1. So we're just going to write that here. Initial guesses, that would be x of I and x of I minus 1. Now our approximation value for the root would be approximation of root would be our x of I plus 1. I write it here so that just in case you want to review it again. So here we could see that we could create a triangle here. This point is our first triangle, and this is our second triangle. We perform simple computations, derivations, so that we would get the formula used for our secant method. So here for our first triangle, we will name it as A, B, C, D, and E. If we take out these triangles here, it would look like this. First triangle would be A, B, and C, and a bigger triangle would be A, B, and E. So that is the approximation value. Now, what we're trying to do here is that we get the ratio of the height, this height, from D to E and C to B. So our height D to E over B to C would be equivalent to the length of D to B over the length of B to A. This is our similar triangles here. So next is that we substitute this D to E by our function here. This would be our function x of I. This point, this would be f of I minus 1, and for this point, that would be our function of x of I plus 1. So we're just going to plug it here. From D to E, that would be our function f of x I over B to C, function of x of I minus 1 is equivalent to D to B. This our x of I minus 1, that would be x of I minus 1 over x of I minus 1 minus x of I plus 1. So by cross multiplication, and that we isolate this x of I plus 1 here because that is our approximation of root, we get a value of x of I plus 1 is equals to x of I minus the function of x of I multiplied by x of I minus x of I minus 1 over function of x of I minus f of x of I minus 1. So this would be our derived formula. Derived formula for secant method. So a secant method is an open method, which means that our value for x here would be outside the bracket or outside the line here, compared to the bisection method and the false position method, sorry for that, where we could guarantee the convergence of the roots. So that is all. Thank you.